Hello, welcome to Introducing Computers Podcast 3. In this episode, we look at how the computer hardware is involved with processing data. Let's dive in. All the components we've talked about, like the CPU, RAM, and cache, exist for one main purpose: to allow the computer to process binary data. Binary data is simply information represented as a series of ones and zeros, which the computer understands and processes. For the computer to do anything, whether it's running a game, typing a document, or browsing the internet, it needs to go through a process called the fetch decode execute cycle. This cycle is at the heart of everything a computer does. Here's how it works. Fetch: the CPU fetches an instruction or piece of data from primary storage, usually from RAM or cache. The memory address register, MAR, helps by holding the address of the data the CPU needs to fetch. Decode: once the data or instruction is fetched, the CPU needs to understand what to do with it. The control unit takes care of this by decoding the instruction, figuring out what action needs to be taken. Execute: the CPU then carries out the instruction. This might involve the Arithmetic Logic Unit, ALU, performing a calculation, moving data around, or making a decision based on the instruction. Store: finally, if any data has been changed, the CPU will store the result back into primary storage. The Memory Data Register, MDR, temporarily holds this data until it's stored. This cycle happens over and over again, millions or even billions of times per second, depending on the CPU. Each component in the CPU, from the registers to the ALU, plays a critical role in ensuring that this cycle happens quickly and efficiently. However, the speed at which the CPU can process data depends on several important characteristics. 1. Clock speed: this is the speed at which the CPU runs its cycles. It's measured in gigahertz, which tells you how many billions of cycles the CPU can complete in a second. The higher the clock speed, the more instructions the CPU can process in a given time. 2. Number of cores: modern CPUs often have multiple cores, which are like mini-CPUs within the main CPU. Each core can handle its own fetch decode execute cycle, so more cores mean the CPU can handle more tasks at the same time. For example, a quad-core CPU has 4 cores, allowing it to process 4 tasks simultaneously, making the computer faster and more efficient at multitasking. 3. Cache memory: cache is a small amount of superfast memory located close to or inside the CPU. It stores copies of frequently used instructions or data so that the CPU doesn't have to fetch them from the slower RAM. The more cache memory a CPU has, the more data it can store close by, which helps to speed up processing. Together, these characteristics determine how powerful and fast a CPU is. A CPU with a high clock speed, multiple cores, and a large cache will be able to process data much quicker and handle more complex tasks without slowing down. So putting it all together, all the components of the CPU, along with primary storage like RAM and cache, work together to allow the computer to execute the fetch decode execute cycle efficiently. The faster this cycle can run, the more quickly the computer can process data and perform tasks. Understanding these key characteristics helps you appreciate how a computer works and why some computers are faster or more powerful than others. And that's it. If you enjoyed the podcast, please do not forget to like and subscribe, as it really helps the channel grow. Until next time. Goodbye.